So for our next work holding method, we're going to start to take a look at the 4-jaw independent chuck. Before we get into the details of the chuck itself, I wanted to go ahead and do some kind of comparison and contrasting to the 3-jaw chuck that we looked at previously, which is the self-centering or concentric or scroll chuck. So as we talked about before, this chuck, as you adjust it, all 3 jaws move at the same time. You can't independently move one jaw. The 4-jaw independent chuck does allow you to individually adjust one jaw in and out at a time. So this has some benefits and some drawbacks. The benefits are we can hold odd shapes in here. We can also precisely center round shapes in here, which we weren't able to easily do with the 3-jaw. The drawback, the main drawback to the 4-jaw is in speed and ease of use. So the 3-jaw, you've seen how quickly we can easily clamp something and be fairly close to center, whereas on the 4-jaw, it's going to take us quite a bit more time to get a piece accurately located in here, although we can make it more accurately located. These are probably the first 2 chucks that you'll end up purchasing for your lathe. These are definitely the most commonly used. Depending on which one you start with, really depends on what type of turning you're doing. Most people will start with a self-centering chuck such as this. These chucks do come in both 3 and 4-jaw, so you can get a 4-jaw self-centering and a 3-jaw self-centering, and you can get a 4-jaw independent as well as a 3-jaw independent. Additionally, as you get to bigger lathes, you can get 6-jaw chucks. You can get chucks that are both self-centering and have independently adjustable jaws. Those are usually quite a bit larger and quite a bit more expensive. I haven't seen anything like that in the Shoreline size range. But you'll want to start with one of these 2. Again, the 3-jaw is probably the more common just because of its ease of use, speed, and simplicity of use compared to the 4-jaw. But if you're doing highly accurate work that needs repeatability and rework, that's really where you would probably start with the 4-jaw. Also, if you're dealing with anything oddly shaped or square or rectangular, the 4-jaw comes into play there. The 3-jaw will mainly hold round or hexagonal items. You're not going to be able to do squares or rectangles or octagons or other odd shapes that you may come across, whereas the 4-jaw will allow you to hold nearly any of those. So that was just what I wanted to do for a quick comparison there. These are the same diameter, so they're the same swing over the bed. They are obviously different thicknesses. As you can see, the 4-jaw is considerably wider than the 3-jaw. The 4-jaw also has a clamping groove on it, which will mainly come into play on the mill, and we'll demonstrate that later once we get to the mill. You'll also notice that the 4-jaw has these rings cut into the face of it. These are to help you with rough alignment of the jaws as you're adjusting them. Now the jaws between the 3 and the 4-jaw are not interchangeable. They're both set and made to be used on one or the other chuck. Something I didn't mention in the 3-jaw video was that you can get replacement jaws, either hardened like these are, so hardened steel, or you can get soft steel, or they have some with replaceable jaws where you can just quickly swap in and out different plastics, like such as Delrin and UHMW, I believe. I don't remember what all their options are. Aluminum jaws, soft steel jaws, things along those lines. So here's a closer view of the 4-jaw. We'll just start concentrating on it. You can see that the jaws are numbered 1, 2, 3, and 4. I haven't yet removed any of the jaws, so I don't know if they are also numbered or not. As of right now, I'm not seeing any numbering on them. These are adjusted simply by using a hex key and turning this screw, and that will move the jaw in or out as you please, and then you can go over to the next one and do the same thing. So I'm going to go ahead and remove one of these jaws entirely. So here I have one of the jaws almost completely out, and we can see how this threaded portion interacts with the jaw. It's got a groove that the jaw sits in and doesn't have a whole lot of play back and forth there. As we go a little bit further, the jaw will come completely free. And as you can see, this is fairly heavily greased with the factory grease still. I haven't taken this apart yet or cleaned it out thoroughly yet from how it comes from the factory. So here we have the jaws. As you can see, it's clearly not going to be the same type of jaw as we saw on the 3-jaw self-centering chuck, so these are not going to be interchangeable. And I have wiped all the grease off of the jaw and looked, and there is no stamping or numbering. Now these jaws shouldn't be different from one another because they are. So each jaw, whether it be in location 1, 2, 3, or 4, the jaws should be nearly identical. However, it's still a good practice because of the slide fit to keep these in the same positions. So you may want to stamp or mark them if you're going to be moving them in and out quite a bit. Additionally, the jaws can be reversed, just as we saw with the 3-jaw, and be placed in that regard. So this will allow us to hold a larger diameter on the inside or outside face of the jaw. I'm going to go ahead and place this back together. So we get the thread started. And you should use some light machine oil, such as showing machine oil. The factory grease is more of a protectorant. I mean, it will definitely work as a lubricant as well. But long term, you're going to want to put something a little bit thinner and lighter in there to allow this to operate smoothly. So it's much simpler mechanically than the 3-jaw. We don't have that scroll. We simply have 4 jaws that ride on a threaded insert or threaded screw with a groove cut in it. And now let's take a look at mounting it on the lathe itself. This mounts in a very similar fashion as what we've seen before. I'm going to put my high-tech bed protector on there so that in case we were to drop it or anything, we're not going to damage the bed. If you want to, you can make one of these out of hardboard and some wood shims, or just use a piece of cardboard as I have here. Again, this attaches pretty much the same way. We just thread it on. It's 3/4 by 16. And now we can remove our protective piece of cardboard. Now, as you can see, this is quite a bit thicker, so we are going to lose a little bit of bed length by using this. And while in previous videos we did take a look at, we used a dial indicator, this last word by Starrett, to basically check the accuracy. In this case, the accuracy is going to be what we decide to make out of it, how finely we choose to adjust these jaws. Along those lines, we're going to be using the dial indicator to indicate or locate the piece rather than check its accuracy. It's somewhat the same type of tasks, but this is really the first time we're going to have to locate a piece before we can start doing any operations on it. And we haven't gone into locating very much in this series of videos yet. On the lathe, locating is fairly simple in that it's usually done with a dial indicator, whether it be a swing arm of this type or a plunge indicator. It's up to you, whatever you prefer. And then center indicating is another item to indicate a hole or things along those lines, or a center punch, which becomes a little bit more complex. So we're going to start with just a simple example of centering in the 4-jaw. So as we start in on mounting this piece, we're going to have to just do a rough center first before we get into using the dial indicator. This is much more time consuming. I'm obviously going to be cutting a lot of it out of the video because you don't want to sit here and watch me turn screws for 30 minutes. So I'll do a lot of it off camera and just kind of give you a summarization of what it is that I'm doing. So now the piece is very roughly centered, and we can turn on our lathe at a slow speed and start to see how far out we are. Now, an easy way to do that is to use either a marker or a pencil and just bring it up slowly. It's best if you've got this on a rest, and we'll see where we contact the piece first. So in this case, this edge where we've got the black mark, no mark anywhere else around it, is the closest to this edge. So we need to turn this jaw in and the opposite jaw out. And since that mark isn't exactly lined up with the jaw, in reality we probably should do two jaws. So we should turn both of these in and both of the opposite side out. So small adjustments are all you really need to do. Then we turn it on again, and we move our marker in slowly until we get another mark. Now we're a little bit closer to center because our mark is a little bit longer there. But we just keep doing this and repeating this process until we're fairly close on. You can use a marker as I'm showing here, or a Sharpie type of marker, since we're going to be turning this away, or a pencil if you're marking a piece that's you need to be able to remove the marks from. It's just, this is going to show up a little bit better on the video. And you just keep repeating that until you've got a mark that goes most of the way around, or you feel you're close enough to bring in your dial indicator and start using it to indicate center. So I'm wanting to center off of this piece of the shaft for our most accurate turning rather than this piece. This was a sample that we were working with in the 3-jaw to demonstrate how you can't reverse a piece and get accurate turning. And we're going to see if in a 4-jaw, if we can get that accuracy and without getting this type of a line and adjustment edge. So as we begin to adjust this, we're going to need to make sure that our indicator doesn't drop off the surface. And right now it appears to be keeping contact, and you can see we have quite a bit of swing still. Now I actually knocked it a little bit further out of alignment on the jaws from where we were doing these marks, just so you can definitely see that swing and see the adjustments that we'll be making. This is our high jaw, which is jaw number 1. So we'll go to the opposite jaw, which is jaw number 3, and back it out slightly. So we just keep repeating this, finding where our high point is. And then we back out the opposite jaw and tighten the jaw where our high point is at. So as you can see, we got fairly close there. We could continue to adjust this as much as we desire, depending on how accurate we want to get the piece centered in there. You're going to get to the point where you're doing barely, an 1/8 or a 1/16 of a turn on these screws, or even less than that, to make these adjustments. So just be aware of that. You're really not going to be turning, multiple revolutions of these screws unless you're very, very far off. Because oftentimes, if you try to adjust it a little bit more, you're going to end up knocking it further out than you intended to. So there we're at about a 1/2 thousandth, I believe. Maybe not even a 1/2 thousandth, maybe a 1/4. Each tick on this indicator is a 1/2 thousandth. So we're pretty well centered there. Now, obviously, if you are doing something that needs a higher level of accuracy than that, then you can continue to try to tweak this. But the amount of time you spend adjusting it is going to be commensurate with how accurate you want it to be. Also, keep in mind, particularly as hobbyists, we'll want to get accuracy down to that 1/1000th or 1/2 thousandth, or sometimes even more if we're particularly obsessive compulsive about it. you really don't need that in most cases, right? All parts, when you manufacture them on a blueprint, they'll typically come and they'll show what their tolerance is. Sometimes that tolerance is 10 thousandths or 20 thousandths. So, you know, always getting down to where you're within a thousandth or 2 or 3 or half a thousandth really isn't necessary on the majority of pieces you're going to work on. Now, if you are making pieces that are extremely high RPM, say part of a turbo for an engine, or part of a jet propulsion engine, say a jet turbine, then you're going to need those. But if you're working on steam engines and just your average everyday projects, you're really not going to need that level of precision. Now this portion out here we know is going to be more out of round because we did turn it in a 3-jaw. So we are going to get some intermittent cuts here on this first portion, but we'll cut up close to these jaws as far as we can. Then we'll end up reversing the piece, recentering it, and seeing if we can get a cut without any discernible line there. Not going to be the easiest thing to do, but we'll see how close we can get. So be careful as you get close to the jaws. So you definitely do not want to impact the jaws. And bring our dial indicator in, get it close to 0. Spin it by hand. You can see we're pretty round on that piece. So I'm just going to, rather than take out all 4 jaws, we just need to loosen 2 jaws. So I'm going to loosen jaw 1. And jaw 2, since we know we're fairly centered there, so we can pull the piece out. Now, I'm not going to pay any attention to which way it was oriented before or after, because that's not going to matter to us. And I'm going to snug up those 2 jaws that I just loosened. Bring our dial indicator in again on our known goods section. Load it roughly to 0 and see how far off we are. Now this was, again, a piece that was turned in a 3-jaw, so obviously we aligned it according to that 3-jaw previously, and that 3-jaw was considerably off from our current readings. So I'm going to loosen jaw 1 about 1/4 of a turn, come to the opposite, which is jaw 3, and tighten it. So we got a little bit better there. Still getting quite a bit of swing though. And now we're showing our high point as near jaw 4. So I'm going to go to its opposite, jaw 2. Loosen it about 1/8 of a turn. Come back to jaw 4. Tighten it down. So now we're getting considerably less swing. Looks like our high point is near jaw 1 again, so we're going to go to its opposite of jaw 3. Just keep repeating this process of finding the high and low points. So there's our low point. There's our high point. Going to go to the opposite. Loosen and tighten. Now, do we make it worse? Do we make it better? Again, this is why on a 4-jaw you are going to spend a lot more time. Again, I'm going to be clipping out portions of this, so you don't have to sit here and watch me adjust each jaw individually. Over time, you'll get better at this as well, and be able to do it a little bit faster. But I'm going to go ahead and try to dial this in off camera the rest of the way as we did on the first round of it, and we'll go from there. Okay, so I've got this dialed in to within about 1,000th, maybe just a hair over. This can really be an exercise in patience for you. If you're trying to get it super accurate. Again, you'll get a feel for the chuck after a period of time. I'd recommend you replace the standard length chuck keys that come with the thing with the longer style, such as this guy here. So that will give you a lot more ability to tweak very small increments. I did just use the standard key. I didn't go down to using the longer key on this guy, but that will make your life easier to have a longer hex key to do very minute adjustments. Let's go ahead and move our indicator out of the way. I'm going to turn our speed up and start taking some light cuts. Now there to the touch, that line is nearly gone. I can still see a little bit of a visible difference. Some of that's probably in surface finish, but we're going to go ahead and make another pass and see if we can't get that a little bit better. Turn up the speed. So that's probably as close as we're going to get. So now from a feel standpoint, there's no line there. You can't feel any ledge or bump anywhere around the piece, including using your fingernail to check. So we're fairly well centered, and we're able to turn that down after flipping it. And this is really the advantage of the 4-jaw. If we'd taken a little bit more time, we could have gotten it even better than we do have here. Although visually, there may be a slight line there. I'm not sure what you're going to be able to see on the camera or not. So we're within a very small variance from one side to another there. Visually, we're not seeing any real difference. Just from a feel standpoint, we're not really seeing any difference. If we were to put a mic on it, and we could possibly find out if there's any difference from one side to the other. But we're not going to be worrying about quite that level of accuracy yet. If you wanted to, you could have spent more time tuning in the chuck, because I did only get it within about 1,000th, so obviously we are going to be a little bit out. And you're not really going to be able to see that 1,000th on here. Again, but there is going to be a slight difference there and variance there. But that's the basics of the 4-jaw. Not going to go into much more detail than that on it. As you can see, it takes a lot more time to set it up, but you do get the advantage of being able to very accurately center a piece. Within 1 or 2 thousandths is very easy. Getting beyond that, you're going to just have to take more time to really just kind of tweak the chuck and fine tune it in. All depends on what you're going for and what level of accuracy you need in the particular parts that you're creating. So I hope you've enjoyed this video. Be sure to give it a thumbs up or subscribe if you liked it. And we'll have 2 to 3 more work holding videos to come.